Today we're going to unravel the concept of observability, a crucial pillar of site reliability engineering. Observability is the ability to detect and diagnose issues in real time. It's an essential part of site reliability engineering. However, many organizations still have room to improve. They often rely on traditional monitoring tools, which only provide a limited view of what's happening. But here's the twist. Observability and monitoring are not the same. While monitoring simply collects data for reporting, observability goes a step further. It's about understanding the health of your system, tracking changes, and getting to grips with how users interact with your platform. Observability is like having a high-powered microscope that lets you see everything happening in your system in real time. So, observability is not just about data, it's about insights. It's about knowing what's happening, why it's happening, and how it's affecting your users. Now that we've understood what observability is, let's delve into how one can achieve it. Achieving observability isn't as daunting as it might seem. It involves methods such as logging, tracing, and metrics. Let's start by understanding each of these methods in detail. First up, logging. Think of logging as the scribe of your system. It diligently records all system events or user activities. Every login, every button clicked, every page accessed, all of it gets logged. This comprehensive record allows us to detect abnormal behavior, identify patterns, and troubleshoot issues. In essence, logging provides a chronicle of your system's life, documenting every significant event that happens. Moving on to tracing. If logging is the scribe, tracing is the detective. It tracks a transaction or a workflow across multiple components in a system. Imagine you're sending a package. You don't just want to know when it was sent and when it arrived. You want to know its journey, every stop it made, every route it took. Similarly, tracing gives you a detailed pathway of a process, helping you understand your system's inner workings and identify any bottlenecks or failures. Lastly, we have metrics. Metrics are like the health checkup of your system. They measure system performance, CPU usage, memory consumption, network latency, and more. Just as a doctor uses your vitals to assess your health, metrics help us gauge the health of our systems. A sudden spike in CPU usage or a slow network can be indicative of an underlying issue. Metrics enable us to catch these issues proactively before they snowball into larger problems. By combining logging, tracing, and metrics, we create a holistic view of our system. They work together to turn raw data into meaningful insights, enabling us to detect and resolve issues before they impact customers. With these methods, we can detect and resolve issues in real time, but how do we ensure that we're doing it right? To ensure that our observability efforts are effective, we need to follow certain best practices, including data collection, analysis, and alerting. Let's start with data collection. As the first step in observability, data collection involves gathering relevant data from different sources. It's like being a detective. You're collecting all the clues that can help you solve the mystery of what's happening in your system. This could range from log files and tracing data to user interactions and system metrics. The more data you collect, the better picture you get of your system's health and performance. Next, we have analysis. Once you've collected all this data, it's time to examine it and identify patterns or anomalies. This is where your detective hat comes in handy again. You're looking for the who-done-it in the data. Are there any unusual spikes in system usage? Any patterns that suggest a problem? This analysis allows you to pinpoint issues and understand their root causes. Finally, we have alerting. Think of this as your alarm system. It's not enough to just collect and analyze data. You need to be notified when something goes wrong in your system. This is where automated alerts come into play. They can notify you in real time when there's an anomaly, giving you the chance to address issues before they escalate and impact your customers. These best practices ensure that our observability efforts are on point. But are there tools that can help us streamline this process? Indeed, there are tools that can help improve observability by providing data analysis and alerting capabilities. They provide the much-needed data analysis capabilities, taking the collected data and transforming it into meaningful, actionable insights. With these tools, you're not just staring at raw, unprocessed data. Instead, you're gleaning valuable information about your system's health, changes, and user interactions. But that's not all. These tools also come equipped with alerting capabilities. Think of them as your vigilant watchmen, always on the lookout for potential issues. The moment they detect a glitch or an anomaly, they send out alerts. This real-time issue detection and resolution capability is a game changer. It allows you to nip problems in the bud before they escalate and impact your customers. In essence, these tools are like your observability command center. They gather, analyze, and interpret data and then alert you to take the necessary action. They are instrumental in making sense of the vast amount of data and turning it into a tool for enhancing system reliability. With these tools, achieving and maintaining observability becomes more efficient and effective. So, whether you're a seasoned site reliability engineer or just stepping into this field, these tools can be your secret weapon for achieving top-notch observability. In conclusion, observability is an indispensable pillar of site reliability engineering. It's the key that unlocks real-time issue detection and diagnosis. By employing methods like logging, tracing, and metrics, we can gain a comprehensive view of our system's health. Following best practices such as vigilant data collection, thorough analysis, and timely alerting, we can maximize the effectiveness of our observability. Remember, observability is not just about data collection. It's about understanding your system's health and ensuring its availability and resilience.